Good day, all. My name is Sonam V. Maju, and I'm a research scholar from Christ University, Bangalore, India. Today, I'm here to give a video presentation of my accepted paper, a novel AI model for the extraction and prediction of Alzheimer disease from the electronic health record, authored by myself and my supervisor, Dr. PRAKASI OS, Christ Deemed to be University, Bangalore, Karnataka, India. The main two concepts, other than technical, that we are discussing in this research paper is the concept of dark data and Alzheimer disease. First, let's discuss about dark data. Dark data is a term which was first introduced by David J. Hatt. So, dark data explains like this. We all are using electronic devices. We all are using multiple electronic devices. Like we are using a smartphone, we are using our laptop, we are using smart watches, and majority of them are using a lot of wearable devices also to monitor their blood pressure and all. So a lot of devices, we are using a lot of devices on the daily basis, which actually, create a lot of data in a millisecond. Like a lot of data is being created from all these electronic devices. And the question is how much of this data is converted into information. Say we have our smartphone with us. There are a lot of duplicate or redundant data in our smartphones. We all are using laptops. What can you imagine what is the amount of redundant data which is there in our laptop? We will have different emails forwarded or replied or copied from one folder to another folder. We have different documents and Excels which will be downloaded and then later segregated to different documents. So a lot of redundant data is there. And in our smart watches and wearable devices, it is actually creating data every millisecond. So we are actually living in a world full of data. The question is how much of this data is actually converted into information. So we all have this much data with us. And second question is how much of this data are we using on a regular basis? So the definition of dark data goes like this. The amount of data which is there in our electronic devices or which is there in our system, which is not used in a regular daily life. Like all this data is there in our system, consuming the space, consuming this time, consuming all the analytical procedures, everything. It is using every storage device, space, and everything. But we are not able to, we have failed to use these data on a regular basis. So that is what dark data is. Even though we are not using it on a daily basis, it is still there in our electronic devices, consuming space and all. So that is what dark data is. The other interesting part is that dark data is present everywhere. It is almost present in every sectors, like talking about the management sector, the organization, institutions, banking sectors, multimedia. It is present everywhere. The very important sector where dark data is present is called the health sector. So we'll discuss how dark data is present in the health sector. In health sector, in almost every colleges, in every hospitals, we are using electronic health records. So every patient is having an electronic health record or EHR, which is transferable from one hospital to another hospital. So all the personal information and the health related information, which is confidential, is available in the electronic health records. But the question is how much of this information is used for the prediction of diseases? Because the data is there every time when we go to the hospitals, the caretakers will take the vitals, they will check our blood pressure, sugar, and everything after a certain age. So all these vitals or all these diseases are getting checked every time when we go to a hospital. And it is there in our electronic health records also. And the interesting part is that these diseases are correlated with a lot of other deadly diseases. So the question is, how much of this information or how much of this data is used as information in predicting other diseases of a particular patient? So as far as this information is used single-handedly or one way for the prediction of a certain disease, if it is not used properly for the prediction of other diseases, these vitals or these readings can be called as dark data because which is there in our system, it is there in our documents, but we have failed to use it for other purposes as well. But it is still there as data, not as information. So that is the presence of dark data in healthcare sector. So dark data is a very important topic that need to be discussed, and it is a very important research topic that is yet to be explored more. So that is one thing that we are using in our research work. The second part is the Alzheimer disease. So Alzheimer disease is a degenerative disease which unfortunately has no cure at all. So once a patient is having Alzheimer disease, then he or she has to take it throughout his life. The interesting part is that the symptoms of Alzheimer disease will be there in the patient from the end of 30s or the starting of 40s. The important part is that this symptoms, by the time the symptoms comes out of our body or it is visible to others, the patient is having that Alzheimer disease. So it is a degenerative disease which has no cure at all. So through our research work, we are trying to say is that as there is no cure in Alzheimer disease, the only way is to predict the Alzheimer disease as early as possible. So how can we predict Alzheimer disease? A lot of studies are happening around the prediction of Alzheimer disease, but through our literature survey, majority of the studies are concentrating on the conventional Alzheimer prediction symptoms, like predicting, like checking a patient through MSME or ETIV or NTIV. So a lot of other conventional symptoms or methods are there to predict Alzheimer's disease, and majority of the research works are happening around these conventional parameters. From the starting of 1990s, there are research paper which is discussing about the correlation of Alzheimer diseases with diseases like diabetes, blood pressure, cholesterol, and all. So there is a very interesting correlation between diabetes, blood pressure, cholesterol, and Alzheimer's. So initially, the discussion was only with diabetes and Alzheimer's. Later, it moved to type 2 diabetes and how it triggers the condition of Alzheimer's. And now last year, there was a paper which actually renaming Alzheimer's as type 3 diabetes, which is a very big statement that explains the correlation of diabetes and Alzheimer's disease. So through research studies, it is very clear that diabetes is a very important disease which can trigger the condition of Alzheimer diseases. Similarly, blood pressure and cholesterol also plays a very important role for triggering the condition of Alzheimer disease. So in this research paper, we are actually using the new parameters like diabetic, cholesterol, and blood pressure, along with the conventional parameters as well. So our research work is divided into three. First, we are extracting data from the electronic health record, which is called as dark data in our research work. And the second step is to use named entity recognition to identify or to divide these entities into the specialities, the medical entities and the non-medical entities. And the third part is the prediction of Alzheimer disease. So now let's move on to the methodology or the research part that we are doing in this paper, or that we have discussed in this paper. So now the entire research work is divided into three sectors. The first sector is to extract the important information which is required for triggering the condition of Alzheimer disease. So we are actually using the electronic health records. We have the records of 5,000 patients. This record involves the discharge summaries, the department the patient visited, and the pharmacy details, the medicines he or she purchased, or the prescription of the doctor, the description that the doctor gave about the patient. All these informations are present in the collected in the EHR record that we have used in this research work. So our first duty is to segregate this data, like which all data we need for our research work, and the other non-medical, not much important for our research work. For that, we are using named entity recognition. So using named entity recognition, we are actually dividing the data through the prescription and description of the doctors through a pre-trained models, predefined categories we are creating, or we are using the existing entities, the existing predefined categories of entities which is available in the named entity recognition. as well as we are using one more, or we are creating one more custom entity, which is called speciality, which actually segregates only the required information of the patients, which actually triggers the condition of Alzheimer disease. So first we will collect the data. So we have 5,000 odd data of the patients, and we will take the description and the prescription part of the doctors. Then we'll do the text pre-processing into this data. The first thing that we are doing is the tokenization. So we will take the data, we will only fetch the information which is actually required for our research work, and which is basically connected. It should be connected to Alzheimer disease. Now, once we get the data, we will use a tokenization. We will divide these words into different tokens. So we are naming the token as T1, T2, T3 up to Tn, and we are combining it together to a set, and we have named it as S. So S is a set which is having a lot of tokens, which is divided or which has been split from the prescription and description of the doctors. And now we have to give a label to these tokens so that we can segregate it as easy as possible. So for giving the labels, we have labeling it as L1, L2, L3 and all. And you are using the annotation of these texts with labels like T1, L1, T2, L2, T3, L3, etc. After that, we are taking it into a different higher dimensional through word embedding. After all this, what we are doing is that now, after all this, then we are creating a custom entity called speciality. After creating the custom entity speciality, all the tokens which is related or which has some relation to Alzheimer disease, which has something to contribute to Alzheimer disease, will be put together in this label, which is called speciality. So after this custom entity has been created, we will use the prediction of the label. For that also, we have introduced or we have mentioned a mathematical, for all these steps, we have given a mathematical concept also in the research paper. So all this, we are using the named entity recognition. For the easiness or for the better performance, we are using SpaCy NCR. So SpaCy is an open source library, and its main functionality is to provide named entity recognition, which is used to identify and classify the entities in a text based on pre-trained models and predefined categories. After all this, we have to check after the prediction is also done, the prediction of the label is done, a new entity has been created, a custom entity has been created. Finally, the loss function is also calculated. So the minimal loss function is also calculated. The mathematical part of that is also discussed in the paper. So mainly the first step or the first part of the research paper is using SpaCy named entity recognition, which starts with the tokenization, where we will take the prescription and description from the electronic health records. We will divide it into different tokens. We will name each tokens, and we will put all these tokens into one dictionary. Later, annotation of text with labels is a second step, where we will name the labels as L1, L2 and all. We will combine the token with the labels like T1, L1, T2, L2, and again we will combine it together and put it in another segment. The third is a word embedding, where we are putting all this information into a higher dimensional space. Okay, once that is done, then we will create a new entity, which is called speciality. Why we are making a new entity? Because we have a lot of non-medical data. We have a lot of data in the EHR record, which is actually at this point, we don't require it in our research work. We need only the data which has some connection with the Alzheimer disease. So for that, we create a new entity called specialties, and all the data or all the keywords or all the text tokens which is related to Alzheimer disease will only be put in this new entity, which is called as a specialty. So now we have the label, we have the tokens. The next step is to prediction of the labels. And those after all this prediction, these data will be put it into this new entity called specialty. After all this, we will check the loss function, and that is the end of the first part of our research work. The second part of our research work is the prediction. So the prediction of Alzheimer disease. Now we have a lot of information which is required to train a machine learning model. So we are using a machine learning model called support vector machine for the prediction of Alzheimer disease. So now we have all the data which is required for the prediction of Alzheimer disease, where we are using both the conventional prediction parameters as well as new symptoms like blood pressure, diabetes, and cholesterol. So after using all this together, we have a data set now with us, which has the conventional parameters as well as the new parameters. So now we have the data ready to train the machine learning model. We are using the support vector machine. So after the prediction, we are giving this data to the support vector machine. Then we understood that there is a problem of dimensionality reduction because our data is having our data points are also pretty high, and we are having 30 plus attributes also to be taken care of. So it was actually showing the problem of dimensionality reduction. So we had to cut down this 30 symptoms to a lesser number. For that, we used a feature selection. So using a feature selection method, we cut down this 30 attributes to 11 attributes. And the very successful or very happy part of this research work is that the attributes or the parameters that we have included along with the conventional parameters, that is diabetes, blood pressure, and cholesterol, we took these parameters through the literature survey. After feature ranking or feature selection, after feature ranking, we selected 11 parameters. These three parameters were also got selected inside the 11 parameters. So in order to avoid the problem of dimensionality reduction, we cut down the 30 parameters to 11 parameters through feature selection and feature ranking. So in feature selection and feature ranking, we have the parameters like blood pressure, cholesterol, and diabetics, as well as other conventional parameters also. Altogether, we have 11 parameters. Dataset is also ready. Now we have to feed these dataset to a machine learning model. The machine learning model we are using in this research work is the support vector machine learning model. So after running this support vector machine learning language in our dataset, we got a very impressive accuracy rate of 90%, more than 90%, but avoiding the loss functions and everything, we can stick on to 95%. And it was very impressive. And we did a comparative study with other machine learning algorithms also to check the dependability of the data set, the extracted, because we are extracting the data from the electronic health record. So in order to check the dependability of this data set for the further research work, we ran multiple machine learning algorithms into the data set, and all the machine learning algorithms were giving very decent, very impressive accuracy rates. And then we had a comparative study with other models, like we had a comparative study with deep learning models. We have a comparative study with other machine learning models. And we did a comparative study with other NLP, natural language processing model also, because NER, named entity recognition, or SpaCy NER, comes under the natural language processing. So in the research paper, we have a table with the comparative study where we have compared our model with the deep learning neural network models, different machine learning models, and the NLP, natural language processing models as well. So this is the crux of the research work that we have done in this research paper. So the entire research work, this is just the first objective of our entire research work. So just taking the conclusion or summarizing the research, the entire research paper. First, there were two new concepts, that was dark data and Alzheimer's. We started with the concept of dark data. Then we explained what dark data is, how dark data is getting formed, and why it is called dark data, and who named this data as dark data. Then we discussed about the Alzheimer disease, like what is Alzheimer disease, why it is an incurable disease, and why it is a degenerative disease. What are the conventional parameters? What are the new parameters? From 1990s, different new parameters were discussing in the research papers, and still that research work is going on. And then we talked how dark data is present in the health sector and how it is connected to Alzheimer disease. Then we came to a methodology. Methodology is divided into three sectors. First is the extraction. Then what is happening in the SpaCy NER extraction, and the third one is the prediction. So we discussed about SpaCy. We discussed about the named entity recognition, how named entity recognition is working, how a new custom entity is being created, and how we are predicting the labels into the named entity relation, and then how we are predicting the Alzheimer's using the machine learning models as well. So as a summary, as concluding this entire research work, the machine learning algorithms are actually giving pretty good accuracy rates and all. But in future, I would like to convert this classical data into the quantum bits. That is a future work that I want to do on this research paper because whenever we do the machine learning algorithms into it, the results will be always binary. Like either the patient is having Alzheimer's or the patient is not having Alzheimer's. Uh, but when we convert this classical data into quantum bits, the concept of superposition will come into picture, the concept of entanglement will come into picture. So I believe that it will be able to give results other than binary, like 70% of a patient having Alzheimer disease or 80% of a patient having Alzheimer disease, which is debatable because naive Bayes can also give a result relatable to this because it is the concept of probability that is being used. But again, I strongly believe that if we are converting this classical data into quantum bits, and if you're using a quantum machine learning algorithms on these data, it should perform in a better way or in a more impressive way by giving better accuracies and better designing models. So that is a future work that I would like to do on this research work. So this is what my video presentation on my accepted paper on this paper. Um, I hope you all got a pretty good clarity on what this research paper is about and what research gap is being discussed and how we are trying to solve the research gaps that has been discussed and all. Hope you all have a good day. Thank you so much.